Why everything in the universe is spinning. The mind-boggling truth, Richard Feynman, pointed toward right now. As you read this, you are spinning literally, not metaphorically. You are riding Earth as it rotates. Earth orbits the sun circles the Milky Way, the galaxy, drifts through space. Nothing is perfectly still, and nothing ever was. This simple observation leads to a disturbing question. Why does everything in the universe spin? Planets spin, stars spin, galaxies spin, even fundamental particles carry something called spin. Richard Feynman never delivered a single speech with that title, but across his lectures he returned again and again to the same brutal idea. Rotation is not an accident. It is built into the structure of physical law. This is not a mystical story. It is the story of one rule, that the universe never breaks: conservation of angular momentum. There is no such thing as absolute rest. Feynman emphasized that motion only exists relative to something else. If you stand still, you are still only compared to the floor, which itself moves with Earth, which itself moves through space. Motion is unavoidable. The better question is not why things spin, but why we ever expect them not to. Motion in straight lines is governed by momentum. Rotational motion is governed by angular momentum. And angular momentum, once it exists, cannot be destroyed. Nature forbids it. If a system starts with even the smallest amount of rotation, it must keep that rotation forever, unless it transfers it elsewhere. This is why an ice skater spins faster when pulling in their arms. The speed changes, but the total angular momentum stays the same. This rule exists because space itself is symmetric under rotation. Turn an experiment, and the laws do not change, because space does not care about direction. Angular momentum cannot vanish. The early universe was not perfectly smooth. Tiny fluctuations in density and motion existed from the beginning. Gravity amplified these imperfections. As clouds of gas collapsed into stars and planets, any small rotation increased dramatically. Like the skater pulling in her arms, collapse reveals spin rather than creates it. This is why stars rotate, planets rotate, and galaxies flatten into disks. Rotation shapes structure across the cosmos. Once spin appears, it becomes unavoidable. Quantum mechanics reveals something far stranger. Electrons have spin, but they are not tiny spinning balls. If they were, their surfaces would move faster than light. Spin at the quantum level is not motion through space. It is an intrinsic property like mass or charge. Yet it obeys the same mathematical rules as rotation. It is conserved, it produces magnetic effects, and it combines exactly like angular momentum. Electrons have spin 1/2, meaning their quantum state requires 2 full rotations to return to itself. Nothing in everyday life behaves this way. Feynman warned students not to visualize this because every picture will be wrong. Quantum spin exists because the underlying quantum fields must respond consistently to rotation. Spin is the cost of symmetry. Spin is not just a curiosity. It builds matter itself. The Pauli exclusion principle forbids identical particles with the same spin from occupying the same state. Without it, atoms collapse. Chemistry vanishes. Solids do not exist. Your hand does not pass through a table because of spin. The stability of matter is enforced by this strange invisible rule. The same mathematical object governs spinning galaxies and quantum particles. Different scales. One law: does the universe itself spin? The question sounds simple but hides a trap. Rotation requires a reference. Earth spins relative to the stars, but the universe contains everything. There is nothing outside it. Ernst Mach suggested that inertia and rotation gain meaning from all the matter in the cosmos. Einstein was inspired by this, but general relativity does not fully obey Mach's principle. Some solutions allow rotating universes even without an external reference. Observations so far show the universe to be nearly isotropic, with no strong global rotation detected. Mostly uniform, but not perfectly. So rotation can be reversed, time cannot. You can spin a wheel forward or backward, but you cannot unspill milk. The arrow of time arises from entropy, not from the laws of motion themselves. Feynman stressed that the equations of physics work both forward and backward in time. Yet the universe began in a state of extremely low entropy. Why remains unknown. Angular momentum is conserved forever. While order dissolves, stars burn out, galaxies drift apart. The universe cools and darkens, but spin survives redistributed endlessly. The universe forgets shape but remembers motion. Feynman refused comforting answers. Nature does not spin for a purpose. It spins because symmetry forbids motion from disappearing. Once motion exists, it must persist. This is not a story of intention. It is a story of inevitability. Everything spins because the universe cannot stop. Hedda full uniform. Look, the canigals an mán na leid a flát místri. Lek, you know, that he